So with 6.5, we did a few different things. We did operations, and then we did the composition. Okay, so we're going to start. Oh, yeah. Okay, we're going to start with the finding each function. So we have to know that this means multiplication, right? So if you have the x squared times root x, this one threw some of us off. If you don't have anything that's outside the radical to combine it with, you have to keep it. So that's just x squared root x. Okay, x squared root x. Now, when you are doing these, you have to make sure that you list any restrictions, and I believe that's the exact language that's on your quiz. Okay, so the restrictions are going to be where the domain is. So the only thing we have here is a radical. So we would also, we'd have to include where x is greater than or equal to 0. It doesn't ask for the domain, so you don't have to do the domain notation here. Okay, for number 2, you are adding g of x and h of x. So you should get x squared plus x minus 8. Okay, and then the domain is all real numbers. There's no restrictions, so we don't have to say anything. When you subtract, you should get x squared minus x plus 8. Make sure that you distributed. Okay, that you distributed the negative.
Oh.
Is that that happened? And like I said, I like to put mine in the parentheses to show that. All right, number 4. This is a good one to go over. So you have 1 over 2x times x squared. So when you have fractions, we have to remember what the rule is. So the rule for this one is going to be, if you're multiplying fractions, you have to do what with them? Yeah, if it's a whole number, put it over 1. I would absolutely recommend that. So then I get x squared over 2x. If you have x squared over 2x, then x times x is the same thing as x squared, right? Well, isn't x squared just x times x? Yeah. So that can remind you that you're going to have to cancel these out. So x divided by x makes 1. So your final answer, you can write this one of 2 ways. You can either keep it as x over 2, okay, or you can have it as 1/2 x. Okay, now you do have a fraction here, but if you were to set the denominator equal to 0, okay, if you were to say, because the denominator is 2 equals 0, is there anything to solve for there?
No.
No, so you don't have to worry about that if there's no variable in the denominator. All right, for 5, you should have x cubed minus 8x squared. Do you guys have questions on that one? You want to do it out together? Oh, we're getting to that. All right, and then number 6 is f divided by g. So you have 1 over 2x, okay, and then divided by x squared. Now, when we see it like this, we know that this is not simplified correctly. It's a fraction within a fraction. But sometimes if you just write it out horizontally, okay, then we can remember what's the rule for dividing fractions. Yeah, you guys keep, change, flip, multiply by the reciprocal. Okay, so 1 over 2x times, what's the reciprocal of x squared?
1 over x.
Okay. So 1 over 2x cubed. Okay, and then from there, this one you do have a fraction, so you have to set that equal to 0 and solve for x. So divide by 2, x cubed equals 0. Take the cube root. What's the cube root of 0? 0. Okay, so x cannot be 0. So you're just going to say where x cannot be 0. Again, the reason why we're not writing that in domain form is because they have not asked for the domain. We're doing operations, not composition. So we haven't got to the composition yet. Okay? I'm going to give you the answers to 7 through 12, and then if there's any that you want to see the work for, that you want to go over together, let me know. I want to go over at least one so we can remember the process. So 7 is 9, 8 is 1, 9 is 121. Yep, 2, 1 over 32, and then negative 1 over 14.
Is that okay if you were to like 1 over negative 14?
For that one, yeah. Usually the negative will apply to the top. Okay, so which one should we do together? All right. So you have f of h of 1. So the first thing you're going to want to do is the h of 1. So you start with the inside. So you have 1 minus 8, which is negative 7. That's what you have to take and plug into f of x. So you do f of negative 7, which is 1 over this. Yeah, so you got the, yeah, that's fine. Sorry, I wasn't sure. Okay. All right, and then the composite functions. So this is where you're plugging one function into the other one. Okay, so we'll start with 13. You have f of g of x. Okay, so you always start with the outside. Your f of x, which is 1 over 2x, and then in the x is where you're going to put the g of x, which is x squared. Multiply those together, and you'll have 1 over 2x squared. Now you do have to do the domain. Okay, so the domain, if it's a fraction, again, we just did one similar to this, you're going to set it equal to 0 and solve. Now x squared, in this case, x squared is equal to 0. So when you take the square root, you get plus or minus 0, but there is no plus or minus in terms of 0. So we're just going to write x such that x cannot be 0. And that's your domain. Alright, and then for 14, your h of g of x. So h of x is x minus 8. Again, I recommend that you put that in, so if you do have to distribute something, you can do that. But this is just going to simplify to x squared minus 8. Now, there's no fraction, there's no radical, there's no log, so the domain is x, such that x is an element in the real number set. And that's what you would write for your final answer. Alright, with 15 you have to be careful. So when you plug this in, you have h of x, which is x minus 8. So x minus 8, you plug in k of x to get root x. So that's simplified. When you're writing that, make sure that you don't extend the radical. Okay, it doesn't go over that. And then when you do the domain, you have a radical. The rule is you always take the radicand and set it greater than or equal to 0. And then to write that in Sattler notation is just x, such that x is greater than or equal to 0. Okay, how'd the first row go?
Yes.
Well, alright. Alright, let's do 16. So 16 I gave you a hint on, right? Yes, no, maybe so? Yes, that's the one where you had to rationalize. So your f of x is 1 over 2 times x. And this you plugged in root x. So if you have 1 over 2 root x, do you guys remember from yesterday what I said? You should multiply by? Yeah, so you can multiply by 2 root x. You can also just multiply by root x. And then I'll tell you how to simplify both of them. So now on the top, 1 times root x is root x. On the bottom, what happens when you do root x times x? Root x, sorry. So nope, this will just, well, square root of x squared. And then so you still have this 2. So 2 times x is 2x. So your final answer for this should be x, root x over 2x. Now the domain is a two-stepper because you have a fraction and a radical. So the first thing you have to do is make sure the denominator can't be 0. So when you solve that, okay, x can't be 0. The second thing is the radical. So we also know x has to be greater than or equal to 0. Well, if it's greater than or equal to 0, but it also can't be 0, how would we write that in the domain? Yes, good. Just x is greater than 0. Okay, so you do have to combine those together. All right, and then for the next one, you have the square root of, when you plug in g of x, it's x squared. This one you can simplify. What's the square root of x squared? X. Okay, so it's x, and then the domain is going to be x, such that x is an element in the real number set. Alright, and then the last one is the square root of x minus 8. It's all underneath there. And then to find the domain, we have x minus 8 is greater than or equal to 0, which is x is greater than or equal to 8. Oh yeah. So then your domain should be x, such that x is greater than or equal to 8. Like that. Okay, how did we do?
Good.
The practice quiz. Oh, 2 factors.